Hi everybody. I have been inspired by the work that we have been doing lately, especially revolving around our math talks. And today I was especially pleased because I received something in my office. The fifth grade team brought down what they had compiled from the last tests, almost 10 years of tests that they tore apart and made sure that they found a question that matched the module that they are teaching right now. And what a great practice for these students, practicing some of the state testing questions that go along with what they are teaching currently. What's also important though as a teacher is to make sure that we take the time to actually model our thinking. Now, when I was a kindergarten teacher, I did a lot of think alouds. And sometimes it might seem that when the kids are older, you don't have to do that as much. But actually, it is just as important when they are older as well. Once they hear your thought process and what you are actually thinking, they start to make connections as well. Because one, they might either be thinking that, or two, they haven't experienced talking through or working through a problem as you have as a teacher. So definitely modeling that, knowing that you're questioning yourself when you were thinking about a problem, is very important, and it's definitely worth the time. I encourage you all to do that, in fact, every single day. And then I encourage you to have the students talk to you about how they work through their problems, because once you hear them too, you can help them, because you'll understand more of maybe what step that they might be getting hung up at, or what direction that they might be going in that is in the wrong direction, and you can steer them towards the correct path. So I'm just going to model for you how I would model my thinking in a classroom. And I actually took a problem from the packet that the fifth grade team gave me. I thought this would be a great idea, plus it definitely made me sharpen up my math skills before doing this. So boys and girls, I would talk about the problem, and I'd read the problem aloud. Rosalva and Jake walked a certain distance each day. They recorded the distances in the table below. I don't necessarily know what that word recorded is. When I think of recording, I think of speaking into something, but maybe in this instance they mean just writing it down. It looks like here's a chart. It says Rosalva in kilometers, and then Jake in meters. And then it has Monday, Tuesday, Wednesday, Thursday. I don't see Friday, Saturday, Sunday here, but I do see a total. Let me go back. It says Rosalva and Jake walked a certain distance each day. They recorded the distances in the table below. Okay, so it looks like Rosalva's is in kilometers and Jake is in meters. Okay. Says, what is the distance in meters between Rosalva's and Jake's total distances walked over 4 days? What is the distance in meters between? Do I have to subtract? Subtract. All right, well, first of all, it says in meters, so that's pretty key. I know this is in meters. Oh, you know what? I think I need to make Rosalva's into meters. Let me think back or look at my chart. I think 1 kilometer is equal to 1,000 meters. So I'm going to have to multiply each of these by 1,000. Okay. So over here on my paper, 1,000. How do I do this again? I know that's 15. Well, wait, I can just move the decimal place. 1, 2, 3, and 5, 0, 0. Oh, okay. That's 1,500. I'll just mark that there so I know what I'm talking about. So if it's 1,000, 1, 2, 3. Oh, okay. 1, 2. Okay, that's 690. 1, 2, 3. Oh, okay. 1040. And then 1, 2, that's 3. Okay, 2,100 meters. Okay, so now I have them all at meters. I guess I have to total them here. It says total. So I'll add those up. 1,500, 690, 1040, 2100, 0, 13, carry the 1, 11, 12, oh no, wait, 11, 12, 13, 1, 2, 3, okay, 5, 3, 3, 0 meters. Okay, I gotta add this up too, let's see, 11, carry the 1, wait a second, 9, 10, 17, 18, 19, 20, 21, 22, carry the 2, 9, 10, 11, 12, 13, and 9 is 22, 2, 3, 4, 5, 6. 6,000. I should really double check that, but all right, let me see, that's meters too. So I think I'm done. It says, what is the distance in meters? Let me go back and make sure. What is the distance in meters between Rosalva's and Jake's total distances walked over 4 days? Well, usually when I subtract left to right, but it looks like Jake actually had more meters. So it says what is the distance in meters between Rosalva and Jake's total distances walked over 4 days? I think they want me to subtract Rosalva's from Jake's. Let's see, 6, 2, 2, 1 minus 5, 3, 3, 0, 1, 12, 9, I'm going to carry from there, 7, 8, 6, 5, right? Well, wait a second. 1. When I do this too fast, I had to borrow here, so that's 12 minus 3 is 9. If I borrowed, I have to take away from here, but oh, I had to borrow from 6, okay. So 891 meters. Is that the answer? 891 meters. Okay, I have it in meters. And it looks like that's the difference between how far they walked. So if I wanted to turn the question around, I would say the distance between Rosalva and Jake, total distance walked, because that's important, that's what they were doing, walked, is 891 meters. And of course, I know I was doing this quickly, so I'm thinking about it. When I go back and do a few more questions, I think I'm going to come back and just double check this, because there's a lot of converting here and a lot of adding and then a subtraction. So I want to definitely double check my numbers, but I want to get on to the next problem, make sure I have enough time while I'm doing this. So that's how I would solve this problem. And that's something too that I would like you to model for students as well, just talking through that, them understanding some of the steps that you would take to solve that. Thanks everyone, and have a great day.